Alright guys, welcome to lecture 1 of topic 2, the 2D vectors. Here are your learning intention and success criteria. Please complete the KS table. Pause the video while you complete this. Okay, so having a look through here, hopefully you can recognize a bit of terminology we need to know. We need to know what are perpendicular components. What does this actually mean? We need to know what is a resultant vector. So again, a bit of terminology there. Finally, we need to know, well, what is this resolution and what is this combination? In terms of skills, we can see we've got two calculate verbs here. Those are both skills, and so we need to be able to calculate perpendicular components and resultant vectors. If we don't know the method, we can't do the skill. And finally, we should be able to do this solve component again, which is another skill there, so we need to use these skills on complex problems. So let's get into it. A bit of a quick recap, because this is a topic that builds off of a previous topic. So in linear motion, we learnt the following things. Firstly, that a vector is something with magnitude and direction. We had some different vectors. So those are our examples from our previous topic. And finally, we learned how to add and how to subtract vectors. Remember, when we add, we are going head to tail. That would be important. Now, if you need to revise any of those skills, you should go back to visit the 1.1 video on vectors. Alternatively, the Unit 3 to 4 book chapter 1.1 does have some information on basic vector revision. Let's have a look at some math skills. There are some important math skills you do need now on top of the algebra that we've been revising for, heavily relying on for the last unit. And these are your trig ratios. You need to be able to do your sine, cosine and tangent ratios. And we need to know our Pythagoras theorem. Remember, a squared plus b squared is c squared. A and b have to be the two short sides at right angles to each other, and c is the hypotenuse. Now, if you are having any sort of issue with that, I recommend going to the math help room or going to this website, nice and big, write it down, go sign up. You can always come see me as well, but you have to have these skills down pat. If you don't, that's what's going to stop you from getting engaged. So let's talk about vectors. Now, one of the really important properties of a vector is that they do not interact with each other at right angles. So if I have something where I have a velocity of 3 to the right and then 4 to the south, this vector here has no effect at all on this vector here. Okay, they don't see each other, they don't care. In specialist mathematics, you might hear about vector projections. The projection of this vector onto this vector is 0. It casts no shadow along this line. This line cannot detect that line at all. If I had something like 6 newtons north and 5 newtons west, same thing. These things are at right angles. They cannot see each other. It doesn't matter what angles they are. If they're at right angles, they cannot see. Now, this is for vectors of the same type. In the motion unit, the vector type doesn't matter too much for this rule, because an acceleration in the east doesn't affect a velocity north. That's because these things are all very connected to each other. Acceleration is change in velocity, force is application of acceleration, or force determines acceleration, and then momentum is change in velocity or application of force. Later on in the track, we will get to learn about magnetism, and we'll find that there are some magnetic principles where a vector of magnetism in one direction will cause a force at a perpendicular direction to it, so they will act at right angles. So we're going to go with this rule. Two vectors of the same type at right angles do not interfere with each other. So I'd probably recommend you write that down. Now, this picture is from something I've seen called a shoot and drop. So we can see here the red ball is falling, while the yellow ball has some initial horizontal motion, and so while it is falling, it is also moving here to the right. Again, we can see this nice parabolic motion. They have the same vertical velocity though, and we can tell this by looking at the relative heights. This one, let's go to a pen, this height here and this height here are the same. This height here is this height here is the same. That's the same. That's the same. Now, these balls here were drawn at the same time. They took a photo at the same time with like a stroboscope effect. And so we can see here that every ball matches up to another one. There's one in there, and then finally there's one in there. Okay, they have the same vertical height, even in my trash drawing, hopefully you can see that a bit there, but their horizontal position, this one here has a changing horizontal position, this one doesn't, and we see they are the same. Now I may have done a demonstration by now, or I may to do a demonstration where I roll a golf ball off the edge of the lab bench and drop one, and we see it hits at the same time. I also have a lovely video of this I placed on the eLearn of a demonstration of this exact apparatus called the shoot and drop, so have a look on that. Okay, let's get into the skills part. So we need to add perpendicular vectors. Now I'm going to cover it the same way the text does, so we'll start with this. When we add two vectors at right angles, we get what is called a resultant vector. So this is a terminology word from the syllabus, so something you can expect on your final exam, and it means the following. A resultant vector is a single vector that is a combination of two or more other vectors. That means it could be 3, 4, 5, 6, 10, 20, 50, doesn't matter. More vectors doesn't make the problem harder, it just makes it longer. So it's not more complex to do, you just got to do more of the same stuff over and over. So you've done 1D vectors. Things go east and west, or things go north and south, or things go up and down. Now we're going to add two vectors that are not parallel. We're going to do two vectors that are perpendicular. So let's use the boat example. A boat travels 4 meters per second east. Remember, we generally draw east to the right on a screen. But it goes across a river, and the river is traveling at 3 meters per second south. So the question is, what is the actual velocity of the boat? We have the velocity from the engines pushing across, and we have the velocity of the river carrying it down. Now, when we add vectors, we draw them head to tail. So my 4 plus 3. I wouldn't put it over here. I'd be able to get the right size, but I would get the wrong magnitude. This is east, and this is south, which tells us that they are 90 degrees apart from each other. So let's draw that little square in there. And remember, our resultant vector is always, and I'll do this in a different color, our resultant vector is always start to finish. Now looking at this shape, about now you should be going, there's my Pythagoras theorem. Okay, there's our resultant vector, we'll call this V for our unknown. We need to work out what that is. Now, when we work this out, we use our Pythagoras theorem. Remember, a squared plus b squared equals c squared. Let's make our substitutions. Oops. 3 squared plus 4 squared equals 5 squared. Equals v squared. I'm sort of jumping to a step at the end. And this is a 3, 4, 5 triangle, that's why I did these numbers. But if we were to actually do that, so 9 plus 16 gives us 25, square root of 25 is 5. V would equal 5 meters per second. Now the question is though, what direction is that? And so our direction we need to label on here. So we have two angles we'll get to do. We always need it where the resultant vector starts, so it has to be in that corner. We'll give that the symbol theta. Now we could have used any trig ratio to solve for theta here. We have all three sides, so I could use my sine ratio, 3 and v being equal to 5. I could use my cosine ratio, 4 and 5, or I could use my tangent ratio, 3 and 4. I would use the tangent ratio simply because it has the least amount of error. These numbers are nice and neat. 3, 4 comes out as being 5, so there's no error in there. But some of your numbers down the track might have error. You don't know that. And so I would always use the tangent ratio. So tan of theta equals opposite over adjacent. Opposite in this case is equal to 3, and adjacent is equal to 4. So that means my theta is equal to arctan of 3 over 4. Now I'm quite happy for you to jump straight to that step if you need to work this out. 3 divided by 4, shift tan of that, gives me 36.87. Do be careful. A lot of you may be putting your calculators into radians for other subjects, and so if you have it in the wrong unit, you will end up with the wrong answer. So be aware of that. Now we need to write our final thing. V is equal to 5 meters per second. Now this angle starts east, goes south, 36.87 degrees south. Okay, if we were to see a question like this on an exam, we might see a box that looks like V equals blank unit, north, east, south, west, blank degree, north, east, south, west, and you would be expected to go, all right, well, 5 is going to go there, it's an east, 36 point, let's just round it off because I've run out of space a little bit, and then circle the south. Okay, and we'd know what decimal places because it would have the values there. Okay, so this is adding vectors. It's pretty straightforward. We use our Pythag to work out the magnitude. We use our tangent ratio to work out the angle. Let's have a look at resolving vectors. So what if we don't have vectors at right angles? For example, we might have something at a 45-degree angle being added to something at a 30-degree angle. To solve that, we firstly need to do what we call resolving the vectors. Now this has a syllabus definition as well. To resolve means to determine the components of a vector, usually at right angles of each other. So this means break it down into its east and west, its north and south, its ups and downs, so that we have a pair. If we had a vector in 3D, we would have 3 values that are all at right angles to each other, and that tells us that they do not affect each other, so we can add them, the components along their separate sections. So add all the easts with the wests, add all the norths with the souths, and add all the ups with the downs without interfering. Okay. You may like to use IJK notation, because I know a lot of you are doing vectors at the moment, and so you might see it like that. I'm fine if you want to use IJK, just make sure you are consistent with your approach. I is normally X, J is normally Y, and K is normally the Z direction. Just be careful not to swap things around. So let's draw our 2 vectors we're going to add. I'm going to add 5 meters at east 45 degrees north. I'm going to add that to 5 meters at east 30 degrees north. So what I firstly really need to ask is, well, how much of this 5 meters here is going to the east? Let's call that east 1. And how much of this is going north? So we'll call that north 1. Same thing here. How much of this is going east? We'll call that east 2. How much is going north? We'll call that north 2. Now I'm going to write it in one step. You should try to develop these skills as you go along, and ask for help if needs be. So east 1, we can see here that it is adjacent, so it's going to be cosine. It's going to equal 5 cosine of my angle 45, and east 2 is going to equal 5 cosine of 30. Let's have a look at the north. North 1 is going to equal 5. This one is opposite the angle, so it's going to be our sine ratio, sine of 45, and this one will be north 2 will be equal to 5 sine of 30. Now sometimes text will say, oh, it's always the sine ratio that gives us the vertical part, it's always the cos ratio that gives us the horizontal part. That is not true. It does depend on what the angle actually is, so be careful with that. So let's work this out. 5 sine 30 is equal to 2.5. That's one of our golden ratios there. 5 sine 45 is equal to 3.54, which means this will also be equal to 3.54 because they are the same thing. 5 cos 30, 4.33. So now we need to add our values up. Apologies. We need to add our east. So our east, that's a wonky looking E, I don't know what I did there, sorry. Our east is going to equal 3.54 plus 4.33. Our north is going to equal 3.54 plus 2.5. So 3.54 plus 4.33 gives us 7.87. 3.54 plus 2.5, 6.04. And so now we have two values. We have this amount of east, ugly looking number, but it's still just a vector saying it's this much east and this much north. To combine them to work out the resultant vector, we need to add them together. So I'll put that as east and that as north. These are both meters as well because we're still dealing with meters. So let's draw that. 7.87 meters east plus 6.04 meters north. Let's draw our resultant vector. Remember, our resultant starts at the start, goes to the finish, and it wouldn't have mattered if we'd done north and then east. We'd still get the same triangle. Okay? The angle would end up being written differently. It would end up being the complement of whatever we get for this value in here. Okay, it would be 90 take this number, and that's why it doesn't really matter which way you write the angle as long as you write it in the right notation. And so now we need to work out, well, let's call this S. This is a displacement, so let's give it the symbol S. Go back to my black. And now we need to work out, well, what is this here? I'm going to rub out this working here at the top because we don't need this anymore. So one problem with having some text on the screen, it does tend to take up quite a lot of working space. Okay, so to work out S, we know that S squared equals 7.87 squared plus 6.04 squared from our Pythagorean theorem. We don't need to write the theorem first, we're not getting tested on that. Okay, we do need to show this because we're showing our calculation. And that gives us an answer, S equals 9.92 meters. We need to work out our angle. Now theta, I'm going to jump straight to the last process. Arctan of opposite 6.04 divided by 7.87. 6.04 divided by 7.87, and I wish for the arctan of this answer. Theta equals 37.5 degrees. So now our answer here, S, equals 9.92 meters, starts at east, 37.5 degrees north. If we had this other one, it would be 52.5 degrees, so it'd be north, 52.5 degrees east. That would also be correct. You wouldn't get marked down for that. It just matters on that how you draw it to show it. So there is always sort of two answers when you have an angle. Okay, now all of these two skills we've just shown here, they are required for the majority of the rest of the unit, and a lot of students find that this is the barrier to actually getting into it, and so it's the barrier for them actually doing well. If you have trouble, you need to come and ask for help. Okay, you cannot avoid it. You might have to give up an afternoon. You might have to spend some time emailing me to get some help. You might have to go and find some videos and practice on Khan Academy, but you've got to get some help. Okay. It doesn't matter how complicated the problem is, you just need to go, is it right angles? Yes. Add them using Pythag and tan. Are they at right angles? No. Let's break them down and turn them into right angles. That's what you do with every vector. Okay. So, in this video we have learnt how to calculate resultant vectors when adding two vectors at right angles, how to break down, call that resolving a vector at an angle into its perpendicular components. Remember, that means at right angles. And finally, how to use these two techniques together to find a final resultant vector. You should be able to do these three success criteria, which I have not updated. I do apologize for that. Those are incorrect success criteria. That is very amateur of me. The success criteria you can find back on the very first part of the video, so go have a look back there. Remember, there's got some calculations, and we've got to be able to solve complex problems. So, entrance tip though, please access the O-Book and download Chapter 1.1 Check Your Learning PDF. Complete questions 3, 4, 7 and 8. Some of the questions around it are very similar to the questions from the chapter we've just finished, also from the topic we've just finished. Remember that these textbooks are written for the main sequence syllabus, so they sort of expect that students who are currently doing this unit haven't seen vectors for anywhere from 3 to 4 months really. We are in a little bit more fortunate position where we do all our vector motion stuff right together. They don't, so it might be a bit easier for us and a little bit harder for them. Okay, but please submit this on the 2.1 space on eLearn. Don't go looking in the topic 1 area, you can look in the topic 2 area now. Thanks guys, happy listening.